So the following is number 56 on page 279. And the problem was you throw a ball of mass of 1.2 kilograms straight up. You observe that it takes 3.1 seconds to go up and down, returning to your hand. Assuming we can neglect air resistance, the time it takes to go up to the top is half of the total time, 1.55 seconds. Note at the top of the momentum is momentarily zero. As it changes from heading upwards to heading downwards, use the momentum principle to determine the speed that the ball had just after it left your hand, then use the energy principle to determine the maximum height above your hand reached by the ball. So to find the speed of the ball, I told you to use the momentum principle, which in this case it would make sense because the time is given. Usually in most scenarios where if the time is not given, you have to use the work energy principle. So because time is given, it told us to use the momentum. So to find A, use the momentum principle, which is delta P equals F net delta T, where so delta P equals M times delta V, and then you just solve for the final velocity, or sorry, the initial velocity, which was equal to VI equals G times delta T. And you get the answer of 15.19 meters per second. So I didn't explain the diagram, but basically we were throwing a ball up straight up, and at the very top the final velocity is zero, because any object, if you throw directly up at the very peak of the trajectory, the very top, it momentarily stops, because even though it was causing the ball to move as you're applying a force in the first place, but that force gradually decreases as because gravity's opposing it. So at the very top, it does become zero. So when we did the delta V equals mg times delta t, we crossed out final velocity because it wouldn't contribute to anything at that point. It's just zero. So that canceled that out. And then to find the final height, I think that's what it was asking. Yeah, find the final height of the ball to use the work energy principle. So if you realize that at the very top, all the kinetic energy is converted to potential energy, it's very easy to solve the problem. So it was basically kinetic energy equals potential energy, and the equation for kinetic energy is 1/2 mv squared equals mgh, and you can just solve for h that way, which was 11.77 meters. So basically overall, because they gave us time, it would be easier to solve the momentum principle. You could solve using the work energy principle, but I think you would have to use numerical analysis and have the time interval very small to find the final velocity. And then you had to know that at the very top, is momentarily at a stop. So therefore, the final velocity is zero. So, oh yeah, also it told us to find the maximum velocity. Well, if you think about the trajectory of the ball, if you say that at the very top it's zero, so if you think in terms of physics, you're throwing something up, and at the very top is zero. That means that at the very bottom, as soon as it leaves your hand, the speed is going to be the highest, because at that point, that's where the most magnitude of force is being applied. And gradually over time, as gravity is pulling down on it, that force is going to decrease. That is what causes it to stop at the top, because at that point, gravity overcomes that force, and then it's going to cause it to move downwards. So, and then the energy work principle. If you know that all the kinetic energy is converted to potential energy at the top, this part is pretty straightforward. So I think that's it. So thank you.